Hi everyone, my name's Katherine Kampf and I'm a program manager working on notebook tooling at Microsoft. I'm super excited to tell you about all of the new and exciting functionalities we've built for Azure Machine Learning Studio notebooks. I appreciate you tuning in and feel free to reach out on Twitter if you run into any issues or have any questions. Thanks. This is my Azure Machine Learning Workspace, which provides a central hub for all of my end-to-end machine learning needs. So I can do things like keep track of data sets I'm working with, monitor experiments I'm running, and build pipelines, all alongside colleagues I may be working with. And a central part of this collaborative machine learning workflow is often the notebooks experience. So I'm super excited to be showing you some of the new functionalities we've built into Studio Notebooks. Here we have a notebook that's going to help us do some bike demand forecasting. And this notebook might look a little different from notebooks you've seen in the past. Studio Notebooks build on top of the Interact project, and we've also added some new and exciting functionalities that we think will make it a great experience for our notebook users. We've also loved working with the Interact community to contribute things like support for IPy widgets, which bring the interactive nature of widgets that you might be familiar with from Jupyter to the Interact canvas. Now you can see here I've done some initial setup, and then I'm getting ready to create compute. And these code cells might look a little similar to what you've seen in Visual Studio Code. That's because we've added support for the Monaco Editor to power every code cell in your notebook. And this provides useful syntax highlighting, as well as things like these indentation visual cues, which make it easy to track your Python indentation and stop those white space errors that often become the bane of my existence. So this code segment's going to create an AML compute cluster that'll allow me to distribute my experimentation, as well as the cluster will auto-scale up or down based on its usage, which makes it super easy to cut down on costs and hopefully keep your manager happy with your spending, unlike me sometimes. So now that we've created our compute cluster, let's take a look at the data we're going to be working with. So I've imported this data set that has information about bike rental demand. And let's take a peek at a few of these rows to get a sense of what features we have available for us. So once this loads up, we're going to have a similar data frame view to what you might have seen in the past when working with libraries like Pandas. And we have information on the weekday of a rental, what the temperature was like outside, the month, etc., which will all likely be useful for helping us predict demand. I'm sure on a sunny Saturday in the summer, there's a lot more bike rentals than a chilly Seattle winter day where you'd just be getting rained on. So this gives us a good sense of the data set we're working with. But since we build on top of Interact, we can also use the Interact Data Explorer to get a better idea of the specifics here. So I'm going to add a couple lines of code that'll make this data render using the Interact Data Explorer, which will provide us a nice table view of our data, as well as some different visualizations we can use, such as a bar chart, box and whisker, etc., to better visualize and understand our data. As well, we can use this filtering to better dive into our data. So for instance, let's say I was evaluating whether or not we should offer a promotion on Sundays. This particular segment, we've only shown 20 rows, but of those 20 rows, we can filter for day 0, which is Sunday, and see that we have 3 entries of bike rentals on Sundays. Now that we've become familiar with our full data set, let's split it into our test and training data set. So we use our training data set to try different algorithms and figure out which features are most important. And then we'll use our test data set to test the accuracy of those algorithms. And I've written some code to break up our data set, but looking at it now, using the name data probably isn't very useful when the other part of our data set is named test. So I'm going to use this new functionality that allows us to change all occurrences of a certain variable name, and I'm going to rename this to train to make it a little more clear what this data set contains. So now I'm going to run this to get a quick visual again to see if this data looks like we expect. And this looks very similar to when we were exploring the full data set above, so we're looking good. and I'm going to run similar set of code on our training data set and see if that's looking all right as well. So based on this, our testing data set, sorry I misspoke there, but our testing data set is looking normal as well. So I think we're ready to configure our automated machine learning work. So with this automated machine learning, I've set up some specific configurations and told AutoML about things like what data we're training over and what information I'm interested in tracking, based things like my error rate, accuracy, etc. So I've configured our experiment and now I'm ready to submit it. So I know that there's a function call I need to run that's submit, but I'm just not sure exactly which parameters I need to go in. So once I add parentheses, I can see this IntelliSense pops up and tells me that I need to add a config parameter. So I've created the AutoML config above. So I'm going to go ahead and use my tab completions to fill in my parameter information and submit this automated machine learning job for execution. So in Studio Notebooks, we've added a language server, which provides those easy completions and parameter information for your function calls, helping you accelerate your notebook editing. So now that I've submitted this experiment, I get a link to my experiments tab where I can monitor the progress as our job executes. So this will help me keep track of what accuracy rates I'm seeing, if I'm seeing any errors, I can see the output logs, etc. So it looks like my run is still being prepared, but here I can see a link to some previous runs I've done of this experiment. Since this is a demo, I've obviously run it quite a few times, and I can go back to even my first run of this experiment and see how different models performed. I've been tracking the RMSE to keep track of my error rates, and I can see those for each of the different algorithms we tried out, as well as my output logs, etc. So I hope this helps you see how the integrated experience in the Studio Workspace really can accelerate your notebook's workflow. And I hope you're as excited as we are about these new functionalities. Thanks again for tuning in to today's demo session. I'm super excited to hear your feedback on the experience, and please feel free to reach out on Twitter with any questions or thoughts you may have. I'll also encourage you to check out our Microsoft Build 2020 announcements, where we're going to be revealing some new functionalities around collaboration and cleaning up your notebooks. Thanks again for tuning in.